Alright, so part of this we're going to be able to blaze through because we've already talked about loops a little bit, but we're going to talk about them a little bit more since we actually hit the chapter. Plus plus is the increment operator, which adds 1. It's the same thing as doing val is equal to val plus 1. If the plus plus precedes the variable, it's the first thing that happens on the line. If it follows the variable, it's the last thing that happens in the statement. If the statement is on its own line, it doesn't matter, you know. But it does matter if it's in a calculation. And we talked about this before. If you do this, A is equal to 3, B is equal to A plus plus. That's different than doing A is equal to 3, B is equal to plus plus A. In one of them, they both wind up being 4. And in the other one of them winds up being 3 and one of them winds up 4. Which one would they both wind up equaling 4?
A plus plus. So
Well, we
B
can
would equal 4.
So we could just step through it. The plus plus at the end, does that mean that A is going to turn into 4 before or after it gets copied into B?
After.
It's going to be after. So A is equal to 4, B is equal to 3. A will get copied into B, and then A will be incremented. That kind of implies that the other one's the answer, but let's work it through logically. The plus plus precedes the A. That means it's the very first thing that happens. So A turns into 4 and then gets copied into B.
So B would be 4.
Yeah. They call that prefix or postfix. I'm not going to ask you to name any exam, but I might ask you a question like that. Along with plus plus, there is also minus minus. I'm skipping most of the slides on that because we've already actually talked about it. You can use it in expressions. This is crazy, but that would take 1 away from num2. It would add it to num1, store it into the result, and then increment num1. This would fail. You can't just increment a result. You have to increment a variable. So no, you can't add num1, num2, and then increment num2. If you want to do that, you would do that. Plus plus actually only works on variables. Cannot be used in relational expressions. Since when? Oh, can be. Okay, I was about to throw a fit. All right. The while loop. There are several different loop structures. There are while loops, there are for loops, and there are do loops. You Java programmers have already probably hit these. The format of the while loop. While expression, do something. Don't put a semicolon here, that breaks it. Never put a semicolon in front of tabbed code. If you have more than one statement, you can use curly braces to block the code off. If you only have one statement, it's optional. I kind of recommend doing it anyways. However, when I'm saving space by typing up here, if it's a single line of code, quite often I will leave it off. How it works. You're cruising down here. You hit this line of code. If the expression is false, it's like an if statement. That doesn't even happen. But if this expression is true, it executes the statement, and then it comes back up here. Checks the expression again. So the expression is evaluated before the statement is done. There's another flow control statement, the do statement, which works the opposite way. The statement is performed before. Kind of like this. So x is equal to 3. While x is greater than 2, do something. Is that going to do a darn thing? Well, yeah, it is. It's going to print 3, and it's going to print wow 1,000,000 times in a row. So that's an infinite loop, printing wow. Why? Because we never updated our condition. The condition never turns false. How about if we change this Same code, but we made it while x is less than 2. Is it going to print anything? No, because this is like an if statement. So this is what's known as a pretest loop. While is a pretest loop. It tests the condition before it goes in it, and if the condition is false, it doesn't execute it at all. There's also a post-test loop called the do loop. Do, see out, wow, while x is less than 2. So if we set x equal to 3 here, and then we have this is a post-test. Condition doesn't get checked until after that's already done.
Does that mean it prints wow?
It would print wow one time. Right.
So if you had, okay, say if x equals 1 and we incremented x, would it print it twice since it already does it once, I guess? Like if you were to do while.
No matter what x is set to, if you have a do loop, this is going to get executed at least once. Right. So let's put these two statements close together and mention that again. For loops, which we haven't hit yet, but we're going to in a moment, are also pretest loops. While is the what if do is the oddball? It's the post-test loop. So generally, you use a do loop if you want to guarantee that the code inside the loop happens at least one time. You use a while loop if it's okay for the code not to happen at all. And when might that be? I mean, it's okay if you don't, if it doesn't happen at all. You could do something like this. See out, give me a positive number. And you set x equal to 0. So then inside your loop, while, now this is stupid, and let's go for it anyways. Okay, so x, cn into x, and then while, nope. My brain's breaking.
You're doing a while loop.
This would have to be a while loop. There's no excuse for doing a do loop. So I don't know why. Yeah, I was talking about while loops, so that's good. So while x is less than 0, we'd want to print an error message and do it again. See out. I have my arrows going the wrong way. No, don't enter a negative number. And then let them do it again. I don't particularly like this style of loop because you do the code twice. You ask them for it, you read it in, then you check it, and if they got it wrong, you have the same code repeated twice. That's why I tend to use while true loops.
I think that was what the problem was with my sphere assignment. I didn't think you were supposed to repeat the code, and you wanted to say you get its loop until they entered a negative diameter. So I was racking my brain trying to figure out why this isn't running. Because usually if you have a while loop, you most likely have an if inside of it, right? Just to check.
Right. You have two, yeah. The other way we can handle this, and I would prefer, is this is typically what's known as a priming read. You read it first, and then if the condition is false, you don't worry about it. But if the condition is true, then you read again. And there's a lot of code that's written like that. Like try to open a file, read a line of data from the file. If there wasn't any line, if there wasn't any code, don't go into it. If there was no data, else process that line and then read the next one. I would write this myself like this. Yeah, you have to do these because we have 3 statements here. If we left the braces off, this would be treated as, it's tabbed, and in Python that would look great. But in Java and C++, it would be treated like this. This would be the only line of code that was repeated.
Even if that's tabbed over?
Yep.
Wow.
C++ doesn't care about tabs. You can remove every tab from your code, make one long line, and it would still work.
It just screams because it's not part of the syntax.
Yeah. So that works. But no, it doesn't. I mean, that completely breaks it, because it would just print, no, don't enter a negative number a million times. And I guess that's what they get, but that's not what we want. That makes sense? Okay.
So when you set x equals to 0, if you put any number more than 0, why would you?
This number actually gets overwritten immediately, so it doesn't matter what it is. Kind of like yours, where you had 1.2 at the beginning, but it doesn't matter. We could do that because the very next thing we do is we rewrite, like that. The way I was going with this, I thought I might have to initialize x to a value, but we don't even have to. So we could have written this like this. Declare our variable while true. That means it's going to be an infinite loop, but we're going to use a break statement to bail out of it.
That's what I.
Yeah, this is my jam here. C out, give me a positive number, and then read it in, CIN into x, and then you use an if statement. If x is less than 0, tell them they're wrong. And then, otherwise, break. Or you could do it vice versa. If x is okay, then break, else print the error message. I'm going to leave it like this. C out, no, don't enter a negative.
Which one will you see more, the while true loops? Because I know, I think I read something about where they try to tell you to avoid using infinite loops or something, even if you have a break statement. I guess they prefer it the other way.
If the code is more than a page, then it's real hard to spot how it's going to exit the loop. If you have more than one exit point, more than one break, it's also very hard. I would only use the while true break for something
Or like a single
easy to
condition.
understand
Okay.
like this.
Okay.
Yeah. If you document the code clearly enough, they ought to be able to spot where the break is. But if you provide a lot of different sneaky ways of breaking out of it, that's really bad. Okay, so that code would work. What's the advantage, in my opinion, of writing it like this is we only have this code in here once. The give me a positive number. Whereas up here, we had that twice. We had that here. I'm going to put that int x above it. But they both do the same thing, logically. But this one has duplicated code. Duplicated code, it tends to be bad because if you make a mistake in it, you have to change it in both places. What if we decided to write this as a function that would ask for the number and return it? Then you would have to remember to put it there and there. So
It's less efficient.
for data entry, I like this loop, but you could do it either way. And really, you could probably jigger this way to get it to work too. I mean, without using a while true. The disadvantage of doing it this way is that it's one level deeper. We had 2 tabs involved in order to get here. We only have 1 tab in this one.
So right there, maybe you could set x equal to 0, and then if x equals 0, have it do that. Because then it would do it anyway, right?
You're still going to have some kind of if statement in order to print the error message.
Yes.
So no matter what, we're either going to use a priming read so that we can print the error message if it goes into the loop, or there's going to be no statement to display. Oh, I didn't finish this. No, don't enter a negative number, else break. Like that. Beak. All right. And really, you could take the braces out if you wanted to shorten it, like this.
Just because you have one line of code, right?
Right, right.
It just looks better with the braces to me. It just looks more like you know what's going on, I guess.
It certainly makes it easier for somebody to jump in and make a change. Because if you have an if statement like this, if x is equal to 0, and then you have cout what And then you give this code to somebody else, they may think, oh, I'm going to add something else here, like errors plus plus. You know. Well, that's not going to work, because errors plus plus is going to happen every single time, because it's really treated like it was that.
Yeah.
So,
Okay.
if you put the braces there, it's a good strong reminder for anybody coming in where to fix how to modify the code. So I prefer to use braces unless I think it's fluffing out the code so much that it's more difficult to read. I dislike the way textbooks
Yeah.
show flowcharts. To me, it ought to be statements and then an arrow coming back and pointing back to the expression, rather than something pointing to before the expression. But whatever, that's a minor quibble. It's pretty clear. If the condition is true, you do something, and then it's checked again.
For Java and C++, well, the first flowcharting assignment I had to do in Java, for some odd reason, we only used like the data processing blocks and triangles. Like if it's input, you know, you're supposed to use like is it a
Yeah,
quadrilateral or something like
in my,
that?
yeah.
Does it really matter, or do you just really just have triangles and rectangles, I guess I could say? Or
Well, they exist for a reason, but if Ken doesn't want you to use the quadrilaterals for your flowcharts, then you abide by his wishes. You could argue that everything in Java is a predefined function, and so every one of them should be in a process block with the bars. But I would put the print statements and the input statements in the tilted quadrilaterals myself. Someday I'll ask him. So while the number is less than 5, print hello, add 1 to the number. You could write that pretty easily. Notice that they don't put the word while in there. A strict flowcharter won't put the word if or while inside their diamond. They'll just assume that you know which one it is based on where the arrow's pointing. If the arrow pointed down here, then you would assume it was an if. If the arrow shows a loop, you would assume it was a while. This isn't a flowcharting class. He's making you draw flowcharts in Java. I'm not making you do it in C++. So while is a pretest loop. The expression is evaluated before the loop executes. This one will never execute. If number is equal to 6, while the number is less than 5, nope. Number never was less than 5, so it's not going to print hello. Watch out for infinite loops. You either have to have a break statement or something that will make the expression become false. Otherwise, the loop doesn't have a way of stopping. It will repeat an infinite number of times. Not really, because you're probably going to shut the computer off or kill the app, but yeah, it's an infinite loop. Here's an infinite loop. Number is equal to 1. While the number is less than 5, print hello. So what's wrong with that code?
Anything less than 5 will get printed hello.
Yeah, and we never increase numbers, so this never becomes false. So it has no way out. Using while for input validation. We just showed an example of that. I'll be curious to see how they do it. Input validation. The process of inspecting data given to the program to see whether it is valid. The while loop can be used to create input routines that reject invalid data, repeating until valid data is entered. Here's how they do it. This is the first way that we did it. Read an item of input. While the input is invalid, display the error message, read the input again. So this textbook is not recommending you use the break statement. They're executing the first, they're recommending the first way we did it. Weird, the character terms are showing up as little Greek male symbols. enter a number less than 10. While the number is greater than or equal to 10, yell at them, let them type it in again. Flowchart for that. Read the first value. That's the priming read, so to speak. Is a value invalid? Yep. Display error message. Let them read another one. Here's another example. They're not using the tilted quadrilaterals, but whatever. Counters. A counter is a variable that is incremented or decremented each time a loop repeats. It can be used to control the execution of the loop, which also makes it the loop control variable. If you're going to use a counter, you tend to initialize it before entering the loop. It has to be initialized before the if statement. Now, when you see the for command, it'll almost look like they're not abiding by this, but they really are. Now, here's our example. Or, no. Let's go ahead and code this one. What this one is going to do is display a table of squares. You know, 1 squared, 2 squared, 3 squared, 4 squared, stuff like that. We can do that ourselves without looking at that slide. So make a new project. I'm going to call this one squares.
Really just got into the habit of just typing the boilerplate instead of copy and pasting. But
I know. It's better for you because you don't always have a boilerplate in front of you.
You know, like how they tell you to, like, I guess, I don't know how it would word it, but like when you put your name and everything in, how it wants you to do like the name of the file, then your name, then
Right.
the link line, and the description. I copy and paste that in all the time because I'm tired of making those stars.
Yeah.
All the way across the screen. I'm like, it takes too long.
We're not going to use strings. Guess I won't put them in there. Using namespace, std. See, I really ought to be coming down harsh on y'all if you don't put comments on them, but I forget to do that too. Other classes will count you off for not putting all your comments in there. Like file name. I should have given it a better file name than source.cpp, but I didn't. My name. The date.
Which you'll probably see me start doing it on assignments just because duties, cramming in the book.
Yeah. And then describe what the program does. This program displays a table of squares and cubes. Ours is going to be even better than theirs. Okay, so we need to find out what number we're going to start at and what number we're going to end at. Now, their version of it hard-coded that rather than ask for input. I'm comfortable doing that, so let's do that. Let's make two integer variables. Int start, I want to start counting at 0. And stop, the stopping point is going to be when it hits 10. Inclusive, actually. Now we need a counter. X, the whole word counter, however we want to use it.
What do I?
I'm just going to use X. We shouldn't use single variable letter variable names, but they're easy to type. So I need to set X equal to start. That's going to be the starting point of my counting. You know what? I am going to make a counter. Don't be lazy, Jeff. You can copy and paste the word counter. It's only 6, 7 letters long. So while our counter is less than or equal to the stop value, less than or equal to 10, we're going to see out the counter, followed by a tab, followed by POW counter to the power of 2, followed by a tab, and I'm putting this on multiple lines, which you don't have to do, times POW counter to the power of 3, and then a tab. No, not a tab there, a new line. and DL. I want to make it pretty. And then we need to increment the counter. Oh, and add that system pause at the end.
I was like, oh man.
System pause.
Are all the system, I guess, are they all strings?
Yeah, yeah. Because it's just issuing a call to the command processor. If you typed in dir, it would run dir. If you wanted to run a batch file or a CMD file, you could put that in there. But we like pause. So it'll say press any key to continue. There are other ways to do that, more portable ways if we were Mac users. The Mac development environment doesn't close the window as soon as it runs, so they get away with not doing that. Otherwise, you could just use another CIN error, you know, into a temporary variable in order to get it to stop.
Let's see what it did.
Alrighty, looked like it worked.
I think it's strange how Monsters, Visual Studios, but you still don't get your output inside of the IDEs.
I wish it would display the output inside the IDE.
That's
But
so
it's spawning it as a completely separate process, but really so do the others. Java runs its output in a Java engine and yet manages to display it in the IDE. But anyways, we live with it. Okay, so that is working. It displayed, you know, this is our counter variable, also our loop control variable. That is one of the results, and that is the other result. We're going to write the same thing now using a for loop. Who cares that we haven't seen a slide yet for a for loop? It's going to be very obvious what it's doing. A for loop is a kind of loop. Okay, let me add some comments to this. This is where you initialize the variable. That's the initialization of the loop control variable. This is the condition. That's our condition, and this is our update of the loop control variable. Pretty much all your while loops are going to need those three things. If you're writing a while true statement, you get to skip that one, but you don't use while true statements with counters. So we have to have these three things. We have to have an initialization, a condition, and an update. The for loop has all of those right there in the header. One loop to bind them all, and in the darkness. Okay, anyways. So it's got the init there, followed by a semicolon, followed by the condition, followed by a semicolon, followed by the update. That's the general syntax, but those actually have to be valid things. So, for counter is equal to start, semicolon. Counter is less than or equal to stop, semicolon. Now I wish I'd made it a single letter. This is going off the side of the screen. Counter plus plus. And I'm just going to copy and paste those three cout statements again. Okay, so those two loops do exactly the same thing. Guess which one I prefer?
The second.
I like the second one. I like the second one because it's more concise, because I never forget to update the counter like I usually do when I'm writing for loops. You can still use a break statement in a for loop, but it's really bad. It's really poor form. Because,
It breaks when you count.
yeah, it's got its own break mechanism built right in. So of course this counter plus plus can be anything. It doesn't just have to be counter plus plus. It could be a function call. It could be something totally bizarre like a print statement. Java is weird, excuse me, C++ is weird in that respect. Java is more strictly controlled. You can't just like stick print statements and stuff like that in the update. I could be wrong about that. You can leave parts of this off. If counter has already been initialized, don't do this because it won't make your code work. You can leave that off. If you are going to use a break statement to exit your loop, you could leave the condition off. If you're going to do the update inside of the code rather than there for whatever reason, you could delete the update. If you're a true nut, you could do this. That's a while true loop right there. Can't think of a reason why you would do it, but you can. You can find ways to pervert the syntax, but that's you know, the proper syntax right there.
Wait, did you control Z all that? Or?
Yeah.
Okay,
Yeah.
I was wondering how you, it's like you copied them all and had them all sitting there and just pasted them all that.
Nope, I wasn't pasting them. I was undoing them. Yep. So when you're done with that, write a while loop that will count from 10 to 100 by tens. Not squares and cubes or whatever. Just make it print 10, 20, 30, 40, 50. And then write a for loop that does the same thing. I can't get all this on the screen at once. Although you can't see it, you can trust that this says counter plus plus. You're not going to use counter plus plus in this case. What are you going to use instead?
Counter plus equals 10.
Right, counter plus equals 10. I guess you could copy and paste counter plus plus 10 times in a row, but that'd be annoying. So the update for these both will be counter plus equals 10, like that.
Would you have to, do we have to change our stop variable to 100 now?
Yeah, just hard code these values. I mean, yeah, you could set start equal to 10 and stop equal to 100, but I want you to write fresh code, not just modify the code that you've got here. Done with the topic of counters, of loops. We can give more examples, like using a loop to calculate the sum of a series of numbers. So we will do that. Why don't we wait until we hit the slide though. So a do while loop. It's a post-test loop, meaning that the test happens after the body of the loop. This is the one loop where you actually have to use a semicolon, but it doesn't break our rule that you never put a semicolon before an opening brace. So it looks like this. Do some statements, then have a test. So get 3 scores. Cout, enter 3 scores, I will average them for you. So you use CIN into score 1, and score 2, and score 3. They stuck all of this in a do loop. so that they can ask at the end, do you wish to do this again? And then the end of the do loop is the word while again is equal to y. And if it is, if that's true, it will repeat the entire code again. And it did this without any kind of priming read. Howsoever, you could do that just as easily with a while loop. Quite often I find it hard to come up with a reason when you would absolutely want to use a do loop rather than a while loop. It's just that the recommendation is if it has to be done at least once, that lends itself to a do loop, but honestly you could probably code it as a while loop as well. So let's go back to our rules up here. You use a do loop if you want to guarantee that the code inside happens at least one time. You use a while loop if it's okay for the code not to happen at all. And you use a for loop to step through a predefined series of values. Now honestly, there's nothing you can do with a for loop that you can't do with a while loop and vice versa. It's just a different syntax. But if you have that syntax, you may as well use it, and the for loop is designed to write code that will step through a predefined series of values.
Did we really go over arrays? I mean, I watched the video.
We watched the video. We haven't hit the chapter on it. I planned to just jump into it, and then I decided, nah, we better do loops first, because loops are an important part of handling arrays.
Because I was going to ask if we could put these things on. I was going to ask if put the scores in an array and do it that way. But
Yeah, we could have.
but I really don't know how to use arrays.
Nothing wrong with talking about that, though. Question is, could we use arrays to print out this table of squares and cubes? And we could. I'm going to write a simpler version of that loop, maybe just a for loop. So in your for statement, you can create your counter variable like that. You don't have to define it beforehand. So I'm going to do what C is equal to 0, C is less than 10, C++. But I have to define my array before we start trying to fill it up. So int squares, and I want there to be 10 ints in this array. And now we're going to fill the squares with the numbers. So this is declaring an array that's got spaces for 10 pieces of data, and we will certainly hit this in another in another chapter. So we're going to step through our values where C is going to equal 0 through 9, and we're going to fill in squares at that specific value is equal to C times C, or POW, whatever. There we go. That would build a table of squares. Now when we're ready to write it out, we would need another for loop. For int C is equal to 0, C is less than 10, C++, C out our number, our counter, followed by a tab, followed by the array at that specific value, and then an ENDL. So you're using two loops. One is setting up your data, and then the other one steps through, iterates through the array. So an array is just a series of variables. Instead of just having one int, we have 10 ints in a row. So why did I make it 10 from 0 to less than 10? Our last one went all the way through 10. The problem is if we made it all the way through 10, that's actually 11 elements. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 11 elements if you go from 0 all the way up to and including 10. If we wanted it to work like that, we'd actually have to change this to 11 because this is a number of elements in the array. If you define the number of elements in the array, then you better not use that value as your so-called index. You can go from 0 all the way up to 1 less than the length of the array. All right, that's enough about arrays for now. So do while loops, a loop always executes at least once. They say that it's useful in menu-driven programs. The for loop, the general format, initialize, perform your test, I was calling that the condition, and then update. In your initialization, you can actually create the variable as well. That's like I did with int space c. For int x is equal to 1, that kind of stuff. It's also a pretest loop. Here's a for loop that would print out the word hello 5 times. Set our counter equal to 1. Keep going as long as the counter is less than or equal to 5. Every time our block of code is done, add 1 to the counter. So the second code was just showing the same code rewritten to use a for loop, a counter that goes from 1 to 10. And we've done that. When to use the for loop? Any situation that clearly requires an initialization, a false, and an update to occur at the end of each iteration. Well, that's also pretty much whenever you use a while. I like my definition better. You use a for loop when you're going to be stepping through a series of values. But you can't, anything you can write in a for loop, you can write in a while loop, and vice versa. That's not true in Python. A for loop is a very different beast. Ways you can mess with your for loop. If you want to, you can initialize 2 variables instead of just 1 in your for loop. I'm not sure that works in Java. So here we're saying, okay, when we start our loop, I want 2 variables. Int x is equal to 1, y is equal to 1. Not sure I see a big advantage to being able to do that, but you can. You can also put 2 things in the update. They mislabeled this. This is not the test expression. That's the update expression. So they initialize 2 variables. They do something here. And then they modify 2 variables. That's dumb. That code does not need 2 variables. Whatever. You can omit the initialization if it has already been done. You just don't put anything before the semicolon. You can declare your variables in the initialization expression. I showed you all that. Int num is equal to 0. I like that. The reason I like it is that the variable is gone by the time you're outside of the for loop. This num variable is local to the block of code inside the for loop, and once you get down here, num no longer exists. Keeping a running total. Say you want to let them enter test scores, that kind of stuff. You can use a while loop to do that. Or if you wanted to add up all the numbers between 1 and 10. Let's do that first. Let's add that to our code. Add the sum of the values 1 to 10. So we need to declare a sum variable, or a total variable, that'll hold all of the values that we're just about to add. So int sum is equal to 0. Now what do we want to use, a while loop or for loop? Up to y'all.
Let's go ahead and use a for loop.
Okay, let's use a for loop. So for, we need a counter variable. I think I could use x. So x is equal to 0. No, 1, because we said from 1 to 10. Keep running while x is less than or equal to 10. Each time, add 1 to x. and then sum plus equals x. Then we can print that out. Sum of 1 through 10 is followed by the sum, followed by ENDL. That's keeping a running total. That's the same basic idea no matter what kind of total you're calculating. Whether you're reading it from an array, whether you're asking the user for data and adding on to it as you go. Might be a while statement in that case, but you know, you'll have a loop and you'll have something that adds on to the total.
How do you define two variables in the first part of the for loop in the initialization? Do they separate them by comma or do they separate
Yeah, by commas. If you wanted to do that, like that. We don't need that for this, but if you used a semicolon, it would think that the next statement was a comparison.
But,
Oh, come look. And when I ran it, the sum of the numbers 1 through 10 is in fact 55. It is correct. All right, sorry, Richard. I stopped the recorder. We did that. I hope you saw that part. If not, pause the recording and type it in. And then we did this part. Cout, please enter 5 test scores, etc. So the average is equal to the total divided by the number of scores, which in this case was 5. Now there's some not so awesome things we are doing here. 5 should probably be stored as a variable. We also might want to let them exit the loop early, you know, enter a test score or -1 to exit. If we were going to do that, I would use a while true loop. Let them enter as many test scores as they want. I'm going to let this run, test this out. You enter test score 1, they made 100, then they made 110, they made 120, and 130, and 140, so the average ought to be 120. Yes.
I know we kind of went over this, but when you define a variable in like a for loop, is it scope only that loop?
Exactly. X here, his scope is only from between here to here, so if we tried to print X out after that, we couldn't.
So score scope is only that, right?
Right. Yeah,
Okay.
so that variable disappears. We can't get a hold of score anymore after we're out of that loop. That's why we declare total outside of the loop.
Okay, that's what I was trying to figure out.
Yeah.
Gotcha.
And we're also, that's why we're able to reuse this counter variable like that over and over and over, because we're not we're defining X only for that loop, and then later on we define X only for that loop again.
Oh, I see what you did with enter test score, the Cout X, it increments which score you're on. Because I was wondering why you did that, but I see why you did
Yeah.
it. It's cool.
We could rewrite that as a while loop. I don't feel like we really need to. So that's an example of a running total. Sentinels, otherwise known as sentinel values. If you know in advance how many test scores they're going to enter, a for loop is perfect. If you don't know how many scores they're going to enter, you'll want to use a while loop instead and use some kind of break or something that'll cause it to exit. The way my brain works is I would use a break. So I'm going to show you how I would do that. enter a series of test scores, use -1 to stop the data entry. So we need a variable to hold our sum. And then we could do this, while true, cout enter a score. Now we need a score variable. We need to read into it. I wish there was a way to define it and read into it at the same time, like there is Java, but it's really not.
Oh, you can do that in Java?
Well, yeah, because Java uses getNext. You can do int c is equal to scanner dot next int, like that.
Oh, but you still have to do the whole new scanner thing at the top, though.
Right,
Okay,
right.
never mind that.
And then sum plus equals score. However, we want to let them enter -1 to exit. So enter a score or -1 to stop, like that. Then we let them type in a score, and if the score is less than 0, or if it's equal to -1, that's our sentinel value. Sentinel meaning what value causes it to stop, then we're going to break. Else we add it to the sum. And I'm not going to use the word else because it's kind of implied, because break would have kicked it out entirely. So this is using a sentinel value. Now there's kind of some problems with this code, one in particular, which is that when we're done and we want to calculate the average, we don't know how many scores were entered. So we probably ought to have a counter as well. So let's define a counter here. And each time we add 1 to the sum, we're also going to want to increment the counter. Right. And so cout average is the sum divided by the counter. This one, the other one we did where we were going from 1 to 5, we could do the same thing here, except if instead of writing if score is equal to -1 break, we probably would use a if based on the counter. Counter plus plus, if counter was greater than or equal to 5, then exit, then break, that kind of thing. I like using for loops if we know the range of values that we're going through. Why didn't we use a for loop here? Honestly, we could have.
So say you left the condition off of the for loop, would that just make it a while true loop? Well, no, because you would still have your initialization and everything.
Right, if we were going to rewrite this as a for loop, it wouldn't look much different. I'm going to do some copying and pasting of the code and then make a change. So we could define our counter inside the loop while, nope, we would want to put our counter outside of the loop. Not totally sure about that. Then for, we could initialize our sum, we could initialize our counter, keep running until score was less than, nope, you don't want to do that. We're not going to have any condition at all.
Yeah.
And then counter plus plus, like that. We don't need these initializations if we've done them here. So I'm going to delete that part. Okay, there's the same code written as a for loop. You see what I mean? You can write either kind almost interchangeably. But I don't see the point of using a for loop if you're not going to take advantage of its full syntax. If all you're using a for loop for is to increment a counter, I don't mind just putting that down at the bottom of the while loop. So for that kind of thing, I would recommend doing it like that. If you don't mind, I'm going to nuke that. And let's note that this is using a sentinel value to stop data entry, to stop a loop. So sentinel is a value in a list that indicates the end of the data. It's a special value that cannot be confused with a valid value. If it's really possible for your student to earn a -1 on their score, you need to pick a different value for the test score. 999, -999, something. And it's used to terminate input if the user does not know how many values will be entered. You know, doesn't bowling always have the same number of scores? You wouldn't need to use a sentinel value for it. But you may be playing some other kind of game where you have no idea how many scores are going to be earned. This is the same thing we did. So enter the points for game 1, enter the points for game 2, 3, 4, 5, and 6. The total points are 34. Now I didn't actually have y'all type this code in. Are we good with that, or do you want to encode the sentinel value code?
That's how it works, so I'm good. But anyone?
Everybody seems to be agreeing that we're good with that. If you needed it in a homework assignment, I'd probably cut and paste the code. Deciding which loop to use. So the while loop is a conditional pretest loop. It iterates as long as a condition exists. You use it for validating input, that's one reason. You use it to read a list of data terminated by a sentinel. The do while loop is a post test. They say you use it for repeating a menu. Okay? It always iterates at least once. I don't know about that. I would just say that, yeah. I would use it if you have code that needs to always happen at least once.
Well, I mean, if you have a menu, you at least want the menu to pop up once, I guess. I don't know.
And you're still going to wind up having an if statement in it. I don't know. I'd have to go back to see their example. Anything can be written with any other kind of loop, really, if you're careful. And the for loop is a pretest loop, where you have built-in expressions for initializing, testing, and updating. If you know the exact number of iterations, or the range of iterations, that's how you want to do it. Nested loops. A nested loop is a loop inside of a loop, just like you can have if statements inside of if statements. Inner loop, outer loop. What do you do with that? For example, we could print a grid.
Or like our IO thing that we did.
Yeah, exactly. We used a nested loop in the IO. We didn't use for though, we used while, right? Yeah. So the inner loop gets executed entirely for every iteration of the outer loop. Here we go. For student is equal to 1, student is less than the number of students, student plus plus. That's the outer loop. For every student, we're going to ask for a series of test scores. So test is equal to 1, test is less than number of tests, test plus plus. Enter the score, add it to the total, blah, blah, blah. And then when it's done doing that, they've entered all the test scores for one student, so we can calculate the average, we could write it out. Now it's time to iterate the outer loop. So it bounces back up here and it increments student. We're now on student 2. And it runs all this again over and over and over up to the number of tests. When it falls through that and we print out the average, it comes back up here. And it'll keep doing that. It'll keep running this one time and then this a whole bunch of times. So the inner loop goes through all the repetitions for each repetition of the outer loop. The inner loop completes sooner than the outer loop. And the total number of repetitions is the inner loop times the outer loop. You know, If it's for x is equal to 1 to 5 as the outer loop, and for y is equal to 1 to 10, you know, it's going to be 5 times 10. There are times when it won't be quite so easy to calculate, but let's play with that just a little bit. Let's write some code that'll make a rectangle out of asterisks. So let's declare two variables. The number of rows. I want a rectangle that is 5 rows long, and the number of columns. Going to be 10 stars by 5 stars. And so my counters I'm going to name R and C, just for which row we're on and which column we're on. So I'm going to start the row at 1 and go until, so int R equals 1, R less than or equal to rows, R plus plus. Now the same kind of thing for columns. 4, int C is equal to 1. C is less than or equal to the number of columns, C plus plus. Now we're in the inner loop. Let's write out to C out an asterisk. So that's going to write out a sequence of asterisks, but once we're done with an entire line of asterisks, then we want to hit a character term. So after that loop, we're going to C out an ENDL. And there's our 10 by 5. Rectangle. If you change the number of rows to 20 and the number of columns to 20, then you'd have a 20 by 20 rectangle. How many dots, how many stars are in it? 5 times 10. Alright guys, why don't we pause and take a break?
No, I need these no more. Cause I
You
had
gotta eat, like, you still gotta eat some carbs though, that, even though it's not.
Yeah,
It's a whole
they've got protein, but they got like specialty candy bars. They are.
Yeah, I ate one time. I was like, this ain't right. It
I
just
know,
doesn't
right?
feel
It don't feel right. It don't taste
It don't
right.
taste
It's
right.
all tardy and everything. You like,
It's like-
people eat these?
Yeah, people actually do that. People are crazy.
Alright guys, let's write a for loop that will print out some of the characters in the ASCII table. So I'm going to take a look at the ASCII table and see where we might want to start counting. Because if we start at 0 or 1, we're going to get a whole bunch of control characters. And I don't want to see nulls and that kind of stuff. Looks to me like if we start at decimal value 32 and go all the way up to 126, that'd be a good choice. Help me remember that. 32 to 126. So, for int x is equal to 32, that's going to be our stopping point. X is less than or equal to 126, that's our stopping point. X plus plus. Now let's see out the character version of x. So we're going to cast x to be a character so that we can, instead of seeing a number, we're going to see the character that that number represents. And I'm not going to put an ENDL because I want it to go in a line. Howsoever, I don't really want it to go, 126 characters in a single row. So I need something that's going to kind of break up that monotony. Maybe a counter. And every time that counter hits like 20 or something like that, we go to a new line. So, why don't we write, I don't know, a variable called column, and we're going to set it equal to 1. every time we write a line out, a character out, we're going to increase the column number. And then we're going to check to see if that column has hit 20. And if it is, we're going to print a character turn and set it back to 1. So if, or we could just do mod, mod 20. If column modulus 20 is equal to 0, if it's evenly divisible by 20, then we want to print out a character turn. C out an END end line. And we're probably going to need another one of those at the very end, after the for statement. Because otherwise, it'll print a whole column, but if it didn't end up, in an exact multiple of 20, then we'd be left hanging at the end of the row. All right, that might actually work. I put it up at the top rather than the bottom so we wouldn't have to keep doing that data entry. So I'm going to kill the program, compile it, and build it and run again. What, did it scroll off?
Huh? No, it just looks funny.
I think mine either scrolled off or it didn't do anything.
Oh, you can scroll up so a little bit more on your.
I wish I could.
Oh. Yeah.
There they are. Okay. So there's our little chart. It looks like I have some kind of little off by 1 error because it only printed 19 in the first and it printed 20 in all the other columns. But
10, 12,
if I'd started the counter at 0 rather than 1, that would fix that. So I'm going to close that box and change it to say column is equal to 0. Then when I run it, it should be a rectangle, as much as it can be. What do I mean by that? Because it doesn't end in an even multiple, kind of a ragged end there. But the rest of it is. So that's the ASCII chart. Characters 32, which is a space, all the way down to 126, which is the tilde.
what is that called? Tilde?
Tilde.
Yeah.
It's used a lot in Spanish.
Mañana.
I remember that from Spanish. That means tomorrow.
Yeah. So it's an accent placed over a Spanish end. It's also just its own symbol if you don't put it,
Over.
at least on the keyboard it's called that. So I bet that some keyboards will let you hit tilde and then end, to type a Spanish end. That'd just be my guess. All right, I can't think of any other brilliant thing to do with for loops at this point. We've got it printing out the rows, the rectangle. We've got it printing out the cute chart of ASCII characters. One thing we will find out is that in this language, when we're playing with arrays, unlike Python and unlike Java, there's no quick way to get the size of the array. There's a hack way of getting it, but the hack doesn't work in all circumstances. So we will grow very annoyed at that as we use arrays. You may not grow annoyed unless you've already used languages which do let you calculate the length of an array very quickly. All right, the rest of this chapter is devoted to using files as data storage. I really wanted to save that for another day, but I'm not sure how to stretch this lecture out to give us some more goodies. Okay, so let me make sure we've covered some other topics that I think are important. If I ask you to convert 00110 to decimal, if that's binary, do you know how to do that? Did we talk about that? I know you've seen it before, so I'm going to ask these guys. Did we do this? Did we do conversion of binary to decimal? All right. The way binary works, well, the way decimal works is that, like, if you have the number 3,921, that's the ones place. That's the tens place. That's the hundreds place. That's the the thousands place. So really that's 10 to the power of 4 in that column, 10 to the power of 3 in that column. No, it's 10 to the power of 3, sorry. 10 to the power of 2, 10 to the power of 1, and 10 to the power of 0. And any number to the power of 0 is 1. So if we have 3921, that means 3 times 10 to the power of 3, which is just a 1 followed by 3 zeros. So it's 3,000. And that's 9 times 10 squared, which is 100, plus 2, which is 20, plus 1. Okay, so we just successfully converted 3,921 to 3,921. Big deal. It's just to remind you of the place values. Ones, tens, 100s, 1,000s. That's decimal. Binary has different place values because binary only has 2 digits, 0 and 1. Our base 10 counting system, so this is base 10 right here, decimal, has 10 values, 0 through 9. Base 2, also known as binary, only has 2 digits, 0 and 1. So we don't have a 10 to the power of 0, a 10 to the power of 1, and a 10 to the power of 2, and a 10 to the power of 3. Excuse me, but I'm just going to copy that. We have 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. And if we had more bits, like this one actually had 5 bits, then we would need to do 2 to the power of 4 there. You go, well, I don't know what 2 to the power of 4 is, but it's real easy if you start counting from the end. That's a 1, that's a 2, that's a 4, that's an 8, that's a 16, and if you kept going, 32, 64, 128, and so on. Sixteen, 8, 4, 2, 1. So, convert 00110 to decimal. How many 16s are in it? No 16s. How many 8s are in it? None. How many 4s are in it? There's 1 4. So 4 plus, how many 2s are there in it? There's 1 2. How many 1s are there in it? So that number is equal to 6. How about convert 11111 to decimal? That's all of them, isn't it? So 16 plus 8 plus 4 plus 2 plus 1 is equal to, I believe, 31. Yeah. Okay. So does that make sense? I'm not going to ask you to go the other way to convert like 26 to binary. It's not that hard of an algorithm. It's just a little bit weird. You have to divide by 2 and then you write down the remainder. And I'll show it to you, but I'm not going to ask it to you on a quiz. Say you have this number, 51 decimal, which I'm going to represent by the parentheses 10, to binary. Here's how you do it. 51 divided by 2 is equal to 25 with a remainder of 1. So 25 divided by 2 is equal to 12 with a remainder of 1. 12 divided by 2 is what? 6 with a remainder of? 6 divided by 2 is 3 with a remainder of 0. 3 divided by 2 is 1 with a remainder of 1. And then 2 divided by 2 is 1.
Where'd you get 2 from? Sorry.
I don't know where I got 2 from. We were actually done at that list, were we not? 1 divided by 2. Yeah, we can't go any further than that. Okay, so we have 5 digits, which means I made a mistake because the largest value you can express in 5 bits is 31. So I've done goofed. That's why I'm not showing you how to convert decimal to binary. The process is correct, but I goofed.
But where it gets you, because I don't see where you step that.
Okay, the other way to do it is really annoying. But how many 32s could we fit into 51? We could fit one 32 in. Once you do that, 51 minus 32 equal to 29. Is that correct?
19. What?
29.
You're right.
Okay, how many 16s could we fit into 29? 1. So you subtract 16 from that, and you get 13. You see what I did? That's the 32's place. That's the 16's place. How many 8s could we fit in 13?
Actually, 51 minus 32 is 19.
19.
Okay, so I was right. I was like, what?
Yeah, you were right.
You were right, okay. So 19 minus 16 is 3. So we filled in that place, which is the 32's place, and then we have the 16's place, and then the 8's place, and the 4, and the 2, and the 1. So it took 132, it took a 16, but how many 8's could we fit into 3? None. How many 4's could we fit into it? How many 2's? So minus 2 is equal to 1. 1.
That was not. It's not really annoying, but it. I guess like.
I guess
if you
we
do it in
should
your
have-
head,
I guess we should have carried it one more. 1 divided by 2 is 0 with a remainder of 1. And can you see now 110011?
Ah, that's cool. I don't understand how that works, but it's cool. The remainder is the number that's.
And so you stop when you hit 0. Let's do another one, a shorter one, 15. 15 divided by 2 is 7, remainder 1. 7 divided by 2 is what? 3, remainder 1. This is going to be all ones, all straight down. So 3 divided by 2 goes in 1. Here's the remainder of 1. 1 divided by 2 is 0 with a remainder of 1. So it's just 1, 1, 1, 1, 1. So, not going to ask you that, but I would like for y'all to be able to do that. I should have given it to you as a homework assignment if I have a question on it over the exam. I guess I'll just hit it again as a reminder on Wednesday, and that'll count. Better to make up some numbers to convert. Oh, heck. I'll give y'all some homework over it. Convert these binary values to decimal base 10. That's going to be part of our homework.
You mean the other way around?
No, I'm not gonna ask you to do the divide by 2 business. So 1101, 0010, 1110, 11011, 110001. There we go. Those 5 numbers. So hexadecimal. The idea behind hexadecimal is that instead of using base 1 or base 2, we use base 16. So how do you do that? Well, you count 1, 2, 3, 4, 5, 6, 7, 8, 9. But now we need an extra, some more digits to get us up to 16. And you don't have to pick A through F. In Russia, they sure didn't because their alphabet starts with different characters. But A, B, C, D, E, and F get us up to 16 different characters. If you wanted to count them out, you would find that to be the case. So in hexadecimal, you have 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, and 16 to the power of 3.
And how long does that go? Does it stop there?
And you could go as many as you needed in order to hold the number. And depending upon the size of the data type, whether it was a 64-bit or a 32-bit int or something like that, then you'd have a limit. So if you had the number if you had the number 12OF, convert 12OF in base 16 to decimal. Okay, 16 to the power of 3 is, I don't know. So we have to pop up here, what's 16 to the power of 3? 4096. I'm going to write those numbers under here. 4096, this is 256, this is 16s, and that's 1. So, how many 4096s do we have in here? We've got 1. So 1 times 4096 plus how many 256s do we have? 2 times 256. How many 16s do we have? 0 plus how many 1s do we have? We've got F. Okay, what does that mean? That's 15. Right. If we were going to count over, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So 15 times 1. So then we would have to add up all those numbers. 496, what's 2 times 50? 512, and then 0, and then 15. And if we added those together, we'd get the answer. 6 plus 2 is 8. 13, carry the 1, 10, 11, 12, carry the 1, 6, and then 4. And I absolutely would not try to do that reverse conversion. Instead of dividing by 2s, maybe you divide by 16s or something like that, but I'm not going to bother. Okay. In base 10. All right, more interestingly, though, is converting binary to hexadecimal and vice versa. So if we were going to count in binary, we'd start off with 0, 0, 0, 0, and go like that. That's kind of like our odometer. Now we've maxed out the 1s column, so what happens when we add 1 to that number? What's the next number after that? 10, or 1, 0. Now we've maxed out the column again. We're going to roll over our odometer. 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, and then 0, 1, 1, 1. In decimal, that means 0, 1, 2, 3, 4, 5, 6, 7. The largest value you can contain in 3 bits is, in fact, 7. There's a way to calculate that. It's 2 to the power of the number of bits minus 1.
So 2 to the power of 3 is 8 minus 1 is 7.
Right. So if you have 8 bits, it's 2 to the power of 8 minus 1. If you have 32 bits, I can't go that high, but we'll do that. 2 to the power of 32 bits minus 1. The largest value you could hold would be that 4 billion number that we've seen before. That's the maximum value that a 32-bit int could hold if it was unsigned. A signed 1 would only go up half as high. And we'll talk about signed versus unsigned in just a minute. I think I've hit that once. Alrighty, so now we're going to do the hex versions of that. Well, since these are all less than 10, they're the same values. So that's the binary, that's the decimal, that's the hex. So let's keep counting. 1000 is, okay, and 1001. What's next? 1010, 1011. Then we roll over. So that's an 8. 1, 2, 4, 8. So we can just count them down. That's a 9. That's a 10. An 11. A 12. A 13. A 14. And a 15. And 15 is the max value that 4 bits can hold. And back when you had really old game systems like the Atari 2600, then they were only capable of displaying, 15 or 16 colors on the screen. And of course, that got better and better and better as the graphic chips had larger bits per register. Alrighty, so an 8 is an 8 in hex, a 9 is a 9. What's a 10 in hexadecimal? It's an A. An 11 is a B, C, D, E, F. So if I give you a hexadecimal number and I ask you to convert it to binary, it's real easy to do. You just do a lookup. Like what if we have this number? Bad 07. Or bad 007. Okay. Well, a B is a what? A B is a, we just use this kind of as a lookup. 1011, that's a B. I'm going to put spaces between them to make them easier to read, but in real life there are no spaces, of course. And an A is a 1010. What's a D? 1101, and then a 0, all zeros. And then a 7, 0111. Wait, there were 2 zeros in a row. Okay. Then you can take the spaces out.
Okay, I didn't know James Bond was that bad.
Yeah, he's real bad. He's one bad. Okay. So anyways, that's how you convert hex to binary. If you have that table in front of you, it's really easy. And I wouldn't do it any other way, honestly. If I didn't have that table in front of me, I would write it down. And then I would have that table in front of me. So what if we had something like this? I'm just going to type in random numbers. It's not going to make up some cute little message like that. Wait, I did 1110 2 times. So what is that? Well, we just do the reverse. We look up that one. What is that number? That's a 9. It's easier when I don't have to count them out. Okay, and what's that one?
12, 14.
Which is E. And this is a 3. That is 9. I did that one twice. Alrighty, and then we have a 4. No, a 2. Followed by a 1. We could rewrite it without all the spaces, and it would be 9E3 921.
So I kind of get
that power is insanely high.
that. So what exactly? How does the E relate to that? Whenever you see, sometimes when we were doing that random number generator thing, and it was just kicking out some crazy numbers with E's and stuff. What is the E? Is that E actually for like exponential? It has nothing to do with this one, or?
Yeah, you have to be careful whether you mean E as a letter, or E meaning exponent, or E as a hexadecimal. So you just basically have to know your context. Okay, so up here in our homework problems, convert this binary value to hex. I'll give you the chart.
I'm gonna try not to use the
Oh, come on. You can do that if you want. Alrighty.
It's gonna be hard. I'm gonna try to test myself.
And then convert this hex value to binary. Dead 007. No, I'm kidding. That'd be mean. Alrighty. 9-8 dead. Okay. So we also need some programming homework as well as this silly stuff. Not that this is really that silly. I do want y'all to have some kind of underlying understanding that what is computer memory is just a sequence of zeros and ones. And then those numbers represent, what they represent to the computer is dependent entirely upon the program that reads those zeros and ones in, whether they mean numbers or whether they're pixels in an image or what. This kind of explains why graphics got better. 16-bit values could go up to 255. So your Nintendo 16 could display at most, your Super Nintendo, could display at most 255 separate colors on the screen, which was better than the 8-bit one. And then the PlayStation came along with 64-bit graphics, which is, that 4 billion number. Obviously a lot more colors on the screen. Same thing for the memory that could be represented. The way your computer determines what it can access in memory is based on some register that has a certain number of bits. If you have a 32-bit machine, then the largest value it could access would be stored in 32 bits, whatever that is. If you have a 64-bit machine, then the largest value could be represented by 64 ones, which is far, far larger. So let's do both of those. I think we've already done. Okay, so 32, or 2 to the power of 32, could hold effectively 4 gigabytes of RAM without any tricks being involved. Whereas a 64-bit machine could hold a lot larger. You could have a huge amount. Yeah, see, there's your E, but that doesn't mean E as in hexadecimal. Huge amount of RAM on a 64-bit machine. Just because the register that contains the memory address you're reading from is 64 bits wide rather than 32. There is more we could do with while loops, but I think we've just about belabored. Alright, so programming homework. Let's see if I already have an assignment cooked up for this part.